Alright guys, what we're looking at today is some review of your exponent rules, your exponent properties. The reason this is super important is because the next section we're going into is all about radicals, and you're going to have to be using these rules for the types of problems we're looking at. So I just wanted to do a quick refresh of the rules, and then we're going to get to some example problems. So a to the 0 power, anything to the 0 power, we talked about this when we did binomial expansion, is 1. Anything to a negative power. The rule is that that is not a happy exponent. We want to make it happy. We want to make it positive. You always have to move it. So a to the negative n actually moves to the bottom. If it were negative on the bottom, it would move to the top. The rule when you're multiplying. If it's a big number, you're still going to multiply it. But when we talk about the exponents with little numbers, you have to apply an exponent rule. The rule when you're multiplying with exponents is you add the exponents together. So then the rule when you divide is you subtract them. When you see a power outside of parentheses, you have to make sure that you distribute that power to both parts. So this is a to the n, b to the n. Same thing when you have a quotient. You have to distribute the power to each part of the quotient, to the numerator and to the denominator. And then we get to the rule that you guys saw on your most recent algebra review is what do you do when you have a power to a power? A power to a power, you have to remember that you're multiplying those. That's the rule. When you see two little exponents right next to each other, when they're not on separate bases. And then the last thing is if a power to a power is multiply, what happens when you actually take a root of a power? Remember, powers and roots are inverses of each other. So this is going to be the inverse operation. You're going to divide. You're not going to see this one today, but it's going to connect to what we do later this chapter. Alright, so looking at this first example, we have the same base, which means we can combine them together. They're both p, and we're multiplying. And we have little exponents. So the rule when we're multiplying, they get their own special rule. We actually add them together. So this is going to be p to the 7th power. In number 2, we're dividing. The little exponents get their own special rule. You're going to subtract them. So it's going to be b to the 6th power. Then we start to get a little bit more complicated here. We have negative exponents in both the top and the bottom. And I have a little story for you, so if you want to listen to a tiny story for just a second. So in the upstairs, if you imagine this as an apartment, in the upstairs apartment we have Miss X, and in the downstairs apartment we have Mr. Y. Both of them right now have negative dispositions about where they live. Miss X really hates that she has to walk up and down the stairs every time she has a dog. She has to go up and down the stairs all the time to take her dog outside. Then Mr. Y really does not like living in the lower one. He has a negative disposition because he hates that Miss X lives above him because she walks around in her high heel shoes and clicks on the ceiling. It's super annoying. So since they both have a negative disposition about where they live, if we switch them, they get to be happy. They get to become positive exponents. So if it's on the bottom, it moves to the top. If it's on the top, it moves to the bottom, and they become positive because now they're happy exponents. All right, let's take a look at number 4. Now we're going to start to put some pieces together. So now you have regular numbers. Regular numbers are still the same operation. So we're just going to multiply the negative 4 and the 5 to get negative 20. But then the exponents get a special operation. The exponents we're adding. So it's 2 plus negative 5. That's a to the negative 3rd power. Now, you have to remember your ancillary is not finished. If you have a negative exponent, you are not allowed to leave any negative exponents in your final answer. The negative 20 can stay. You can have a negative number. But the negative exponent, you always have to make it happy. That one's going to move to the bottom, and it becomes positive 3 on the bottom. And then this last one is an example with division. The big numbers get the same operation we usually would. Think of that as a fraction. 24 over 3 is just going to turn into an 8. And then we have to go through for each of these variables here and decide what to do. So the a on the bottom technically has a 1 next to it. We are subtracting when we divide. So we're subtracting here. So we have 2 minus 1 is going to be a to the 1st power. Be careful with the b. That's really 4 minus negative 2, which changes to plus a positive. So b is going to be to the 6th power. And then the last part, the C, that's going to be 3 minus 3, which is 0, which makes sense because you should kind of see there they're going to cancel each other out. So we can put c to the 0 power, but just realize c to the 0 power, we talked about on the other page, turns into 1. So this is just 8ab to the 6th. All right, I'm going to give you a couple problems to try now. So try them, and then there'll be another part to the video. All right, so this is the next part. We're going to start dealing with the powers. So if you have a power to a power, this is where you're supposed to multiply when they're right next to each other. So this is going to become x to the 15th power. In number 7 down here, when you have a power and you have multiple things inside the parentheses, you have to make sure you distribute it. So it's going to be 5 with a little 4 next to it, big 5, little 4. And then it's going to be x to the, we're multiplying because those are both little numbers. So make sure you keep the relationship between your little numbers and your big numbers separate. So now we have to actually physically take 5 to the 4th power. That's 5 times 5 times 5 times 5, which is 625. And then remember what has to happen with our x to the negative 8th. It's negative, it's not happy. We can't leave it like that in our final answer. We have to move it. X to the 8th moves to the bottom. All right, so now we're adding another step in on number 8. We have more things. The 3 goes to each part. With the whole number, the negative 3, it's a big negative 3 with a little positive 3 attached to it. And then with the x, we're multiplying. You get the 12th power. And with the y, we're multiplying because those are both little exponents. So we multiply those. Now with this negative 3, I technically should have put it in parentheses before. We're taking it to the 3rd power. So that's saying negative 3 times another negative 3 times another negative 3. So it's going to stay negative. When it's an odd exponent, it'll stay negative. So that's negative 27, x to the 12th. And then I didn't leave myself enough room there. So I'm just going to write in negative 6 again. But we're not allowed to keep it like that. The negative 27 can stay because it's a regular number. But that exponent cannot stay negative. It has to become positive, so we're going to move it to the bottom. So there's your answer for that one. Then we got 2 more to go. This one we have to distribute that squared to everything. So it's got to be 2 squared, and it's got to be 3 squared. And then a is going to be the 6th power, b is going to be squared. The a on the bottom is to the 12th power, and the b on the bottom is to the negative 8. Now there's always more than one way to do this. If you wanted to simplify the a's and b's first, you could have. But I decided to distribute first. So we get 4 over 9 as our whole numbers, our big numbers. And then we have to decide what operation we're doing for our variables, for the exponents. So the exponents on the a's are going to need to subtract. My rule is I just do the biggest number minus the smallest number. But wherever the bigger amount were, that's where your a's have to stay. So since more of the a's were on the bottom, when I do 12 minus 6, the a has to stay on the bottom. It's a to the 6 on the bottom. If you subtracted top to bottom, you'd get negative 6, and you'd still have to move it to the bottom. So this just kind of saves you a step. And then when we look at the b's, we got to do 2 minus negative 8. Minus minus changes to plus positive. So the b, with the bigger one was on the top, the b is going to stay on the top. So final answer is 4b to the 10th over 9, a to the 6th. All right, so this is the last problem. If we were doing this in class, I would have had you try this one. You can kind of pick where you want to start. You could combine the x's and y's together first. You can distribute first. I tend to just jump to the distributing part, so that's what I'm going to do first. We're going to get x to the 6th, x to the negative 9th, y to the 3rd, over x to the 15th, and y to the negative 4th. The next thing I would do is go ahead, since there's more than one x on the top, our goal, I don't think I said this yet, but our goal is to get only one of each letter. So in your final answer, you can't have 2 a's, you can't have 2 b's, you want one of each variable to be represented. So I'm going to start combining those on the top. So that's going to be x to the negative 3rd. We're adding. When we multiply, the special operation we do is adding. And then y to the 3rd is still there. The bottom is still x to the 15th, y to the negative 4th. Now that we have one of each variable, now I'm going to deal with the dividing. So when I divide those, I'm really subtracting. And again, remember my rule. I try to subtract the bigger one minus the smaller one. But then it stays where the bigger one is. So I'm going to subtract bigger minus smaller. But it stays where the bigger is. So the bigger one out of negative 15, or negative 3 and 15 is 15. So I'm going to do 15 minus negative 3, which really changes to plus positive. And I'm going to have x to the 18th, but it's going to stay on the bottom because that's where more of them were. And then I look at my y's. My y's, the bigger one's on top, so I'm going to do 3 minus negative 4. You can do plus positive. That's going to be 7, so I'm going to have y to the 7th on the top. Now the other thing you could do, if you don't like the subtracting thing, is you could move things. I can give you a little other option over here. You could take the negatives and move them. Move this here, move that there. You'd have y to the 3rd times y to the 4th on the top. You'd have x to the 15th times x to the 3rd on the bottom. And you still get the same answer. So there's always more than one way to do these. It's just making sure you're using the rules properly. You're multiplying where you're supposed to multiply, add where you're supposed to add, subtract where you're supposed to subtract. And then just making sure that you don't leave any negatives in your final answer. Okay? So try these next couple problems that I'm going to give you on Edpuzzle, and then your goal is to make sure your homework is done to the best of your ability because I'm collecting it on Monday. Have a great weekend.